let's look at a different scenario that can happen when we're solving in a right triangle. This is how far away from a 90-foot building are you standing if the angle of elevation from your feet to the sun is 14.5 degrees. Uh, this might be a new concept. Angle of elevation. When you think about elevation, you think about things that go up and down, right? Objects that elevate. Usually, this connotates that things are going up. So an angle of elevation is always measured from a horizontal plane swinging up. So here's our 90-foot building. We're going to just do this crude drawing here. Here's our 90-foot building right here, okay? And you're standing a certain distance away from this building, presumably on flat ground, okay? So you're here. Here's you, okay? And the angle of elevation from your feet to the top of to the sun, to the top of the building, it basically, with the sun behind it, I guess that maybe I should have phrased this question a little better, but the sun would be here casting a shadow down. The angle of elevation from your feet to the sun, which we'll put over here, okay, behind the building, and here is the shadow, is 14.5 degrees, right? And they want to know how far away from the building are you standing. That would be this value x. So again, we can assume you're on flat ground. We can assume the building is perpendicular to the ground. So we have a right triangle. Okay, the angle of elevation has to be measured from a horizontal plane swinging up, right? And we use the word swinging, kind of like a door, right? So this invisible line represents the sun rays that are coming through here. And always meeting on the ground at your feet. So when you have this right triangle, you have these two pieces of information. And again, what sides do we have? We have this side, which is the opposite side. Okay, we have this side, which is the hypotenuse, which doesn't affect this problem for what we know. And we want to know this side, which would make that the adjacent side. So again, similar to a problem we saw earlier, we have the opposite side and the adjacent side are the two sides related to the angle that we know and that are of interest in this problem. So the opposite and adjacent ratio is tangent. So that means that the tangent of 14.5 is equal to the opposite side over the adjacent side. So it would look like this. Now, when we're solving this equation, it's a little different from this one, right? When we were using tangent in this problem, we had the unknown value here divided by 7. So all we had to do was multiply to do the inverse operation. In this problem, we're putting our variable, or the variable is in the denominator of this, okay? So we've seen this multiple times. If you're a student of mine, I've talked about this lots and lots and lots up to this point. I call it the switcheroo, okay? And the switcheroo is basically taking an unknown, or taking the denominator. When you have an equation where one side is not a fraction and the other side is only a fraction, right? I don't have any other terms outside here. And if the value you're solving for is completely contained in the denominator, we basically switch these two, or we swap these two values out. And even though this arrow is pointing at 14.5, I also mentioned in a previous video, this is a trigonometric package, right? So I'm not removing the 14.5, I'm taking this entire expression, moving it into the denominator here. So when the variable that you're solving for is in the denominator of the fraction, we can swap it out completely, and then we get a totally different equation, right? That would look like this. And this is something that you can type exactly into whichever calculator you're using, Desmos, TI Nspire, what have you. Okay, what do I have here? I've got Desmos queued up, so we'll just use this. So 90 over the tangent of 14.5. Okay, again, anytime you're using a graphing calculator, if it's Desmos, click the wrench and make sure that degrees is toggled. So you can see when this is degrees, right, we get 348. When it's radians, we get negative 34. So even in this case, you'd be like, how can I be negative 34 feet away from a building, right? So this is the only answer that actually makes sense when you think about it that way, okay? In a TI Nspire, you can do the same thing. If you're looking to get that fraction bar in a TI Nspire, okay, you can click the control button and then the divided by button, Okay, it's not like a computer, like a QWERTY keyboard where you have to click and hold control. You don't have to click and hold this control button. This is like the old school button that said second, right? Like you had in your old scientific calculators where you went to your second function on the button, right? If you just click this once and then click divided by, you get that skeleton of a fraction there, and then we can type in 90 over our tangent value is in here, the tangent of 14.5, and we get that approximately 348 feet. Okay, so we'll say here, like I said, we like to round to 2 decimal places. I think, yeah, that would round to just 348 feet. Okay, so again, the switcheroo we use when the value we're solving for is in the denominator, and we move the entire trigonometric package out and move that variable in its place.